everyone, and welcome back to part 2 of our remote control engineering series. In our previous video, we explored what remote control is and the basic principles behind how it communicates with electronic devices. Today, we are taking a step back in time. I'll be honest, for a long time I thought the history of technology was the most boring part of learning electronics. I only cared about how circuits work. But the more I learned about how electronic devices are designed, the more I realized that to truly understand technology, you first need to understand why it was invented and what problem it was designed to solve. So, let's go back to where the story of the remote control really began. It all started in 1898 at New York's Madison Square Garden. Nikola Tesla shocked a crowd by wirelessly steering a miniature iron boat in a pool. Some people even believed it was magic or that a trained monkey was hidden inside the boat. Tesla called it the teleautomaton. Tele means distant and automaton, self-moving. The secret was an antenna connected to a coherer, a glass tube filled with loose metal fillings. Normally, these fillings had high electrical resistance, but when Tesla's radio transmitter sent a pulse, the fillings clumped together. Their resistance dropped, and they completed a DC circuit board. Each pulse moved a rotary switch one step and changing the boat's direction. Tesla proved that wireless signals could send commands to machines, not just messages. For the first time, machines no longer needed physical wires for every command. But there was still one major limitation. His system could only perform a fixed sequence of actions and couldn't easily distinguish between different commands. So, 5 years later, in 1903, Spanish engineer Leonardo Torres Quevedo created the Telekino. Tele comes distant and quintos means movement. However, Tesla's boat could only execute commands in a fixed sequence. Torres Quevedo wanted something far more flexible. He engineered a system that could count the number of incoming radio telegraph pulses. If the Telekino received 3 pulses, it executed command A. If it received 4 pulses, it executed command B. By doing this, he created the world's very first digital command protocol over the air, using it to navigate boats and early tricycles from miles away. For the first time, a machine could recognize different commands instead of simply reacting to a signal. This was an early step toward the digital communication protocols used in today's electronics. But before this technology could reach our living rooms, the world was about to enter 2 devastating wars. So, when World War first erupted, this technology became a weapon. The German Imperial Navy developed FL boats, remote control speedboats packed with explosive street via heavy cables from shore station to armed allied warship. By World War II, wires were cut entirely as the military poured massive funding into stable radio frequency control. The Germans developed the Fritz X, an armor-piercing glide bomb guided by a joystick from a parent aircraft via an RF radio link. On the Allied side, Project Aphrodite stripped down old B-70 bombers, loaded them with 20,000 pounds of explosives, and used radio channels to fly them, like giant kamikaze drones. This wartime demands rapidly advanced multi-channel transmitters and signal filtering. Although these technologies were developed for war, they also solved some of the biggest engineering challenges of wireless communication. So what they do, increasing range, improving signal stability, and reducing interference, those breakthroughs would later make consumer remote controls possible. After the wars, engineers began asking a different question. Instead of controlling weapons, what if this technology could make everyday life easier? In 1950s, Zenith introduced the Lazy Bones, the world's first television remote control. It allowed people to change the channels from the comfort of their couch. But there was one big problem. It was connected to the TV by a thick cable that people constantly tripped over, oops, and even pets loved chewing on it. So, to eliminate the wire, Eugene Polley introduced the Flash-Matic in 1955, shaped like a plastic ray gun. It transmits a narrow beam of visible light toward four photosensors built into the corners of the television. Each sensor controlled a different function, such as changing channels or adjusting the volume. The idea worked, but a new engineer problem quickly appeared. On sunny days, sunlight hitting the TV could trigger those same sensors, causing the televisions to change channels or raise the volume or even switch itself off. So, to solve the sunlight problem, physicist Robert Adler, we are here, introduced the Zenith space comet. In 1956, inspired by the excitement of the space age. Even more impressive, it didn't need batteries. Inside the remote were four aluminum rods. Pressing a button caused a tiny hammer to strike one of the rods, producing an ultrasonic sound between 34 and 42 kHz. Microphones inside the television detect these frequencies and activate the motorized channel selector. Because every button produced a distinct mechanical click, generation of people simply called the remote the clicker. Once again, engineers had solved one problem, but uncovered another. Household sounds like jiggling keys, dropping coins, or even barking dog could sometimes produce similar ultrasonic frequencies and accidentally trigger the television. This limitation pushed engineers toward an entirely different solution. And what are they? So, by the late 1970s, ultrasonic sound was replaced by a new technology, infrared IR. By using invisible light, engineers developed a far more reliable communication system that was unaffected by everyday household noise. During the 1980s, the rapid spread of VCRs and cable TV boxes meant people suddenly had to deal with multiple remote controls. To solve this problem, universal remotes were introduced, capable of storing thousands of different command codes. Infrared technology went on to become the global standard for remote controls for more than 3 decades. But the story didn't end there. In the early 2000s, radio frequency technology allowed remotes to operate without requiring a direct line of sight. Soon after, Bluetooth introduced secure two-way communication, paving the way for voice control and more advanced user experiences. Today, AI-powered remotes allows us to control our TVs and smart home devices with a single spoken command. But no matter how advanced these remotes become, every remote still relies on one of four fundamental communication technologies. So, let's explore them one by one. Let's start with the type of remote that most people still use every day, the infrared IR remote. So, how does it actually work? When you press a button, an internal microcontroller generates a specific binary data packet and pulses the IR LED at 38 kHz. The TV receiver decodes these pulses back into commands. Why has infrared survived for more than 40 years? Because they are incredibly cheap to manufacture, highly reliable, and consume almost zero idle power, meaning batteries can last for years. Unfortunately, this technology isn't ideal in every situation. They require a strict line of sight. Infrared light acts like a flashlight beam. If a coffee mug or a pad blocks the path, the signal is completely cut off.
Wait, so if there is a wall between the remote and the TV, it won't work either?
Exactly, that's because infrared uses light, and light can't pass through solid objects. We needed a different solution, and that's where radio frequency or RF came in. When you need a signal to travel through solid objects, you use a radio frequency or RF remote. These are standard for garage doors, security gates, and ceiling fans. But what's happening behind this scenes? Instead of light, they use electromagnetic radio waves operating on unlicensed ICM bands, typically 433 MHz or 350 MHz. The internal chip modulates the digital data onto the radio wave using amplitude shift keying ASK or frequency shift keying FSK. Why do engineers still choose this technology today? Radio waves easily punch right through drywall, wood, and glass doors. You can hide your components completely out of sight in a closed cabinet and they will work. Of course, there's a catch. The RF spectrum is crowded, leading to potential cross-device interference. Additionally, legacy RF systems without rolling code encryption can be easily intercepted or cloned by hackers using basic radio sniffing tools. RF solved the line of sight problem, but engineers want something even smarter: faster pairing, secure communication, and two-way interaction. That's where Bluetooth changed the game. Today, Bluetooth has become the standard for most streaming devices and smart TVs. Most modern remotes use Bluetooth Low Energy (BLE). Let's see how engineers made this possible. Operating on the 2.4 GHz band, unlike IR or traditional RF, Bluetooth remotes do not just scream data into the void like IR or RF. Instead, they form an encrypted bidirectional paired connection directly with the host device. For many applications, this is the perfect solution. No line of sight is required, and the high bandwidth two-way communication allows for advanced interactive features. This is why modern remotes can support built-in headphone jacks, touchpad gestures, and integrated MEMS microphones for voice commands. This design also has a few weaknesses because they maintain an active digital connection. They consume significantly more power than IR remotes, meaning you will find yourself sweeping or recharging batteries much more frequently. Bluetooth continues to evolve. The latest Bluetooth LE IoT and RCAS technologies allow lower power consumption, lower latency, and the ability to broadcast IoT to multiple devices simultaneously. This makes modern remotes even more responsive and efficient for smart entertainment systems.
So, if Bluetooth is already so smart, why do I even need another type of remote?
Good question. What if you didn't need a dedicated remote at all? What if your smartphone could control everything? That's exactly the idea behind Wi-Fi smart remotes. The final category doesn't always require a dedicated remote, Wi-Fi and smart IoT remotes. Here's the engineering behind it. This method uses your existing smartphone or a dedicated smart hub. When you tap a button on a virtual remote app, your phone transmits standard network packets over your home router using TCP, IP, or MQTT protocols directly to the smart TV's IP address. This design offers several important advantages. It consolidates your controls onto a device you already own. Furthermore, smart hubs can bridge technologies, receiving a Wi-Fi command from your phone or Alexa and then blasting out a legacy IR or RF signal to turn on an old amplifier, uniting your entire home ecosystem. This method uses your smartphone or smart hub to send commands over your home Wi-Fi network directly to your devices. The biggest advantage is convenience. One phone can control your entire smart home. And smart hubs can even translate Wi-Fi commands into older IR or RF signals for legacy devices. Of course, if your Wi-Fi network goes offline, many of these controls stop working. But connecting devices was only the first step. The next challenge was making them understand us. That's where AI comes in. AI-powered remotes can understand natural language, learn your viewing habits, recommend content automatically, recognize different users by voice, and even control an entire smart home through a signal conversation. The remote is no longer just a controller, it is becoming an intelligent assistant. From Tesla's first wireless experiment to today's smart remotes, this tiny device has become an incredible piece of engineering. But the story isn't over yet. In the future, remote controls may disappear completely and will control all the devices in our homes, simply by speaking, using hands, gestures, or with smart wearable devices. In the next episode, we'll leave history behind and take a closer look at the remote itself, exploring its external design, buttons, and the engineer's decision behind every part. If you enjoyed this video, let me know in the comments, and I'll see you in the next one. Bye!